All right, so I believe we might be getting online in most of the streams right now. And yeah, let's just get started right away. So this is Sunday here in Vancouver and all over the world probably. Some places might be already Monday. So happy Monday or happy Sunday for you, whatever you are. This is about 10:30 at night here in Vancouver, and I am getting a few minutes out of my day here available to work on some facial rigging and some Python. Literally, we are coding live and we are solving problems and moving one step after the other towards the goal of a automated process for a face rig, which is it can be a hybrid between blend shapes and joint based rig, as it should. I guess there's no other way, right? This is the tools that we have on the industry, unless someone innovates and overtakes Maya, which is doesn't seem to be the case anytime soon. Or I mean, it could be, but who knows? So as usual, Bob's going to be spinning infinitely here by our side. How's it going, Bob? Hope you're doing great this Sunday and you had a great weekend. Just looking all over the world with your mouth open like this. But thanks for being a good buddy here. And if you want to participate, you can always drop a few comments here and we'll be chatting about life, rigging Python, and I don't know, sometimes even cooking. And here we go. It's this thing here that we're working on. And the problem that we have in hands in the place that I stopped last stream was mirroring the controls. So right now, it's all already working. All the controls are rebuilding properly, and we are able to then save shapes and build the rig and save the shapes as we please. But in order to mirror the shapes, we still need to do some work. So, and we need to adjust this ones here, but the thing is we are able to now set the controls to whatever we want, whatever shape we want. So we can grab one control like this one guy here and just set it to whatever kind of shape we want, and then just save it, and it's going to be saving as data, as a JSON file, not as a Maya file or anything like that. It's always going to be uh, building the controls basically on an automated fashion with the standard type of shape, which is this cube here. And then after it is done building, then we import the shapes, and then it's going to change the type of shape that it has, and or the type of form that it has, and move the control to whatever the position was before, or the position that was saved. And right now this is what we have, but we are able to then set the shape of this guy here, for example, which is the clavicle control. But then if we need to mirror it, well, we don't have a way to mirror it so far, and the way that we have it is not working. So I'm trying to then work on this in a way that it doesn't get confusing. And it already is getting a little bit confusing because I'm adding flags to a few of the methods here. So I have this get position data that should return us the position data of the control vertex in local space. But in order to mirror, I'm feeling that we're gonna be better off with a world space query, because uh, it's independent of orientation, or so say the joint is oriented in a mirrored position to the other, to on the other side, that will give us a position that might not be the same position in the local space. So if you have the mirror working in world space, we're 100% going to get the position exactly as like an exact mirror from the other side. Now the problem is the get position data inside of the control class is getting the positions in local space. And then if we start to work with this thing of like adding flags to get in local or in, I mean, I just don't want to make the code be confusing. And I wanna, lately, let me talk to you about this. Let me talk to you about this. Whoever, lately, I've been getting cold, and I've been reading cold that sometimes it's just a headache when you start to get into the spaghetti code, as they call it, which is just a nightmare where everything is kind of interconnected, and you move one thing in one of the methods, and you start to break thing in like in a cascade style. This is just, oh man. So I'm kind of traumatized with this right now, and I just want to make things as separated as possible, because when you start, and especially to read stuff, so enough of my face now. When you start to read code, and you have to think of different variables also. This flag here is changing the whole behavior of, or the whole interpretation of the whole code, or the whole section of the code, and then you start to see the same thing, and it's hard to understand. That's not going to help anyone, especially building the foundation of this code. I'd rather have a solid foundation that we can rely and not get back too much later, than having a bunch of flags that are just going to make everything so much more confusing. That being said, then let's get into the code and let's keep doing it. So control mirror selected, that's the thing that we want. Basically, it is getting the control selection. So basically, it is a utility function that we have inside of the tree here on the post build utilities, and it's here control mirror selected. So you just select the control, whichever control you want to mirror, then it's going to get the vertex position here, and just get the mirror control, which is this guy, just changing the R from the left from the right, and then it should mirror the positions, and paste it inside this guy. But that is easier said than done, right? So also, let me do one thing here for the family. See if I can do it really quick. So my daughter made 2-year-old last this Saturday, and we have had a little party. Yeah, I'm gonna do this right now, and yeah, cool. So let's keep going. Okay, so we are querying, we are getting this. So I'm also using this flag here to mirror. I don't feel like this is the best option. I'd like to, so restore positions from position from data should be always restored. Like instead of, oh no, baby's awake. This might take a while, guys. Sorry about that. Calma, amor, tô indo. Okay, guys, so we have a baby on the living room. Likely, this is not gonna last long. Let me change the light settings here because we're a bit on the dark side here. Let's just change this here. Let's increase the gain a little bit. Okay, so I had to reduce a little bit of the lighting because the baby's on the living room. I had to pick her up. She woke up. All right, so as I was saying, I'm just trying to restore the positions here. So let's keep going. Okay, so I have a flag here. I don't like this flag. Let me check this function again. This is just mirroring the position. I don't like that. That so I should whatever I do, I should get the position and mirror it on the method that is the utility, because it's not the responsibility of restore position shape position from data to mirror anything. Even if you're telling it, or even if you are able to do it, it's just not, it's just like yeah, this shouldn't be the responsibility of, this should be straightforward, like restore shape position from data. Why would restore shape position from data be responsible? Sorry, I'm actually with my face on the screen here. So we have this function here, restore shape position from data, and yeah, I want to remove this option here from like this flag here. This is not going to work. Let me see where this function is being called. There should be only one place or two places, I don't know. I'm just checking where else I am calling this function. I know at least two places are calling this function, because the import control shapes must have it. Yeah, so it's just two places. This one here is taking advantage of this flag. I don't like this flag. I'm removing it. I don't want my code to be any more confusing, and I'm taking this out. So then I still need to mirror it, right? So let's then keep figuring out here how to do it. So why is yeah, just complaining that this could be a static function. I don't mind about that. Just checking here. Yeah, so as I said, we are on a family house. My daughter was went to sleep. My wife is taking care, minding her business, and now the baby was crying. I had to pick her up. Now she's on the couch, so I'm like checking if she's all right. At the same time as I try to figure a rigging problem here. So then let's figure out how can we restore this position from data. So I'm getting the position. So what I can do though is get the position data. I would it wouldn't be bad if I could pick up the position data from world space, because the position data can be the position data get position data is being specific about position. So I don't think it would be a problem if we would have like word space here, like a flag, right? I don't think that this would make anything more confusing, because then all I would need to do is just add a simple gate here. So if word space, then we're going to be getting this position from world space. That's simple. I'm just duplicating here, saying else get the position from not from world space, and then this world space. True. All right, so this would then give us the position either in word space or local space. And the importance of having it, or at least in the code that I'm writing, the importance of having it in local space is because whatever the change that you do on the transform. So say you have, yeah, whatever joint you have, if you want to change the orientation of the joint or anything like that, the control that is going to be added automatically is going to be respecting that orientation. It's going to be parent constrained, but initially the system is going to query the position of the joint or whatever you're adding the control to, and using the exact same transformations. So then if you change the rotation or change the position, the control should change respecting that modifications. And that's why you're using the local space, because if you use the local space, whatever happens to the transform is going to affect the position of the control. And now using world space though, it would always get stuck to the same place in world space. Whatever the transform or the modifications we make to the joint, for example, it's not going to change the position of the controls. So let's keep pushing here. So all I need then is to get the position from world space. And here I am actually saying that word space equals true, no, equals word space equals false. Let me check Mia here. She's all right. Okay, so let's keep pushing then. I think then that if we got the positions from world space and we are then mirroring just the information of the shapes, the control data. Restore position. I think that even the restore position then, because I restore shape position from data, then I could in theory do it, have another flag here as well. I mean, I don't know if that's healthy, but let's try that. That's the only way I can think of it right now. Because given that it is a position The exploring position Xform also has a word space flag. That's why I'm actually using this choice of word. So it's not like mirror. Like when I had the flag mirror, I was actually using a requesting this particular method here to do something that it's not even on the helm of position, or it is on the helm of position, but it's just executing a different task, a different operation, which shouldn't be its responsibility. So just control did this and then else. I'm gonna add a world space, and then do true. Oh, yeah. But what I could do also is just have the flag itself here. Why is it complaining? Missing. Okay, so that's irrelevant. Okay, so this then should give us what we need, maybe. So now what I need to do is also then to mirror the positions. So yeah, so what I'm just going to do is do a quick for here. So for, and I know that the data structure is just a diction, it's just a list here. So for control, so for vertex position in control data shape name. So each of the shape nodes has a bunch of vertex on it, right? So then that's what we're doing here. I'm just going to mirror the shape, the vertex inside of each shape node. So now it's the list, and then what I need is a new list here. So vertex position mirror list, vertex mirror position list, was the list, and then vertex position mirror list dot or mirror position equals to the vertex position x times -1, vertex position 1 b. Right, so Mia is complaining a little bit. Just a second. All right, so we're back. Okay, so here we go. Mirror position. The position then has been mirrored, so it's XYZ. And I could possibly have a list comprehension, but I can optimize this later. I'm just going to do this right now. And mirror position. And then I'm just going to append this guy. So vertex and mirror position list. And then I'm going to apply the data. And this should give us something. Let's see. I don't know. Not sure that's going to work. But it might be better than the previous approach that I had. If we get it, awesome. If we don't, just do it again. Let's see if not anything breaks. Hopefully not. So far, no errors. Great. Okay, the position was successfully restored. Now, all I need to know is if the control will be mirrored correctly. And it is. Yes. Fuck yeah, man. Great. Awesome. One less problem to deal with. Perfect. Okay, so I can actually export this positions and try to rebuild it. Export control shapes. Also need to add any sort of response here. Yeah, this is actually giving us a feedback. Export control shapes, but why is it printing double printing the thing? Remove this thing here. Okay, so I was having a double print here. So you can see that this was printed and then this was printed again. This is not what we need. What I need is just one of this, and this should be good for us. Now I can rebuild it and let's see if it works. We should have the same positions now and already with position mirrored. So this is a good. So this is a testament to what happened last stream. Like I spent almost another extra 40 minutes trying to solve this problem, and then you come in with a fresh mind, and then boom, we got it. Even with the like baby crying and stuff, we got it. So sometimes you just gotta have a little rest, and you may get your stuff sorted out. Okay, so it's rebuilding properly. Awesome. That's exactly what we needed. So we have the main control being able to drag everything along. and then you have the global control. That's all working, so great. Starting to look like an actual real rig here. So now the next thing would be to add new shapes to this rig, meaning, or to this class, because right now the ones that we have, it's just too little. The shapes that we have available are, let's see if we can check it out here. So control set shape from, so we have the class here, and we can see that, let me cancel this, and we can see that there's only a handful of shapes here. So cube, arrow, diamond, move, crown, cross, sphere, cube on base, fist, single rotate, foot rotation. So this is not good. You know, I need a bunch of basic primary shapes here in order to be able to. So the good thing about the system, maybe it's a good thing that I might be able to explain this actually. Let me see if I can grab my tablet here. Maybe we can even use some of these things. Is it even working though? Okay, so let me see if I can toggle. How's the toggle display? Okay, so I have the tablet here. Let me see, maybe this is a good experience. Let's see if that works. That'll be clunky here right now. Okay, so it's just picking up the pace. Let me see if I remember everything. So we have let me try to grab like a red here. Huh, that might be a good thing, a good way to explain abstract concepts here. So let's talk about, say, a shape like, which one we have here? Okay. What is it? Okay, so let's talk about like a half sphere like this. So a half sphere then would be like a, or a half circle. So we have a starting point here and an end point here. So this is looking on like a top view, right? So let's say you have all this vertex here, and so this is then encompassed inside of a shape. So a shape is nothing more than a what? It's nothing more than a word space, so like a matrix, let's put it this way. So this is world zero, and then you have the vertex positions in each of these positions here. So this is, so again, looking like a top view, this would be in world zero. It's like if we were looking like this one here. So this is the vision that oh my God, no. Okay, so this is the vision that we would be representing there, right? So this is our transform, and this is our shape. And then what we are doing to restore it then on a three-dimensional space is we are getting the positions from this vertex inside of this shape here. So then, let me see, how can I represent this? This is a cube, right? Oh, so, yeah, but still it's not easy to convey the idea, but let's try. So I don't think we're going to be able to. Yeah, let's say that our shape is inside of this cube here. So we have the information about how to build this initial shape here. So this shape will be then in world zero, right? So this is the raw shape. So let's say that when you, what the information that I have stored here in my curve shape poles here, or so I don't know the name or whatever, but this is how to build the very basic shape, the very initial shape, which is this one guy here. So in world zero, the points should be here, and then you have this shape. Then when you place the control on the rig, so say it is around a joint here, all right? So basically what you did is you picked this guy up here and you moved it into this position here in world space. So let's say that the world zero is here. So it's no longer on world zero. Now it is in this position. So before it was like this, right? And we can even change the color or something like that. Like blue, I don't know. So originally it was like this, and now it is here. So what you're saying is, first of all, the script is knows the exact amount of vertex here, because you say we have stored that the shape, that so this shape, how to build this shape here, for example. So then we have x amount of vertex here. So first of all, it's going to create this shape on world zero, and then so on the, when after we place the controls on the rig, on the position and on the scale that we want, then we export the position. So when we're bringing back the information that we have stored is what's the name of the shape. So this is like half circle. And this here, so what's going to do is first, it's going to set this control. So initially it is a small cube, right? Just like we can see here. Oh my God. So we can see here, for these guys here, they are not set. They're like a small cube, right? So the first action that it's going to do is set or rebuild the control to the raw shape. So this thing here. So then we know that the raw shape is this half circle, say for example. And then, so then it's going to set the control to the raw shape. And then we know exactly how many vertex. And so the information, it's not like it's having to uh, get the amount of vertex, rebuild the entire shape. No, we have already a preset that is called half circle, and it's always going to have the same amount of vertex. So it's always going to have the amount of vertex that we're seeing there. You know what I mean? And then, given that we know the positions and the initial position, or it doesn't even matter the initial position, but we have stored the position of the half circle when we modified it, then it's just setting this vertex back into the position. So the whole thing is like being able to have a preset that is the half circle, and then after you have this, being able to change from one shape to the other. So basically, how to separate this is the transform and the shape are two different things. So you can rebuild the form on another transform and reparent the transform into the current position that we have, and that, and use the world zero to place it whatever it is. I don't know if that's very you know, pretty clear information. That, again, I'm just doing this on the fly. This is a live development session on a Sunday, and I am actually drawing on my tablet or on my Cintiq here, that I don't remember the last time I did it. I hope this is clear enough, but this is how we are restoring the position of the shapes here, of these guys here. So the position initially comes as a cube. The first action then is to set, for example, for this guy here, then we set this shape here to sphere, and then knowing the exact amount of vertex and the exact amount of shapes inside of this. So you can see here that we had three shape nodes inside of a transform. So for this guy here, when we store the position, we are also storing the names of the shapes. So we know how many vertex we have for each shape node, and then we are just placing we're storing the shapes and the vertex, and then we're just doing it again, restoring this information when we're getting back. All right. is it is it is it reasonable? Is it reasonable? Is it asking too much? Restoring the position of shapes. God damn it, let's go. Let's keep pushing. So it's working. Now we are able then to mirror the shapes, and that's how it's going. Though I do need more shapes than that. And do I want to focus on this? I don't know. I mean, I need to keep moving. But I will need more shapes in the future. And I don't think I think it's going to pay off if we just invest a little more time into adding this functionality of being able to add new shapes so that I can use them in the future. Because what's going to happen if I don't do this in the future, I'm going to need it and I'm going to have to recode it or re-understand what I'm saying here, like what I'm thinking, and that's going to take more time than if I just do it right now. So in the beginning here we are, this path here is actually hard coded, and this is also something that I need to change, and I'm going to add this to my list. So remove hard coded path to JSON. Oh god, add dynamic. How do you even write dynamic? I forgot. Okay, thank you. Add dynamic path. So dynamic path in this case is like just getting because right here, right now, it's like getting it from my computer path, right? Well, what I need is to actually get something like whatever TP tools here, but behind that we need to query it from whatever computer you are using, so that if you get this code, then you can just use the same system, no problem. Right now you're probably gonna have issues soon, but it is getting the JSON, and inside of the JSON then we have the data about how to build each of the raw shapes. Now I need to be able to add more raw shapes. So first of all, I need to be able to decompose the whatever shape I do. So if I want to create a new shape, I should be able to. And right now we do have this ability, which is the get position, get data position or whatever. But I also need to be able to add it to this dictionary here, which is the raw dictionary. Okay, so let me just think of how to do it. I'll try to do it quickly so that we can move on. So the curve dict, the transform, then build curve from data. This is what it's doing. And the data structure is then the name of or this one is actually the one. It's the data structure is the name of the shape, a shape, and then we have P, K, D, per, which I never know. Actually, this thing is with the knots. It's just so annoying to me. I cannot understand the reason behind these knots on a curve. I mean, I always see it, but it's like 0, 0, 0, 1, 2, 2, 2. I know if you look at the documentation, they always, but look here, for example, we have a different, here is 0, 1, 2, 3, 4, 5. So this is something that I don't really understand. It says that it's like really actually the same amount of but I really don't know. It doesn't seem to make a difference, but there's a lot of repetition sometimes, and I just don't understand. And so I'm just looking at this the data structure so that I can uh, figure out a way to add new shapes from. So what I would do is I would get here into the scene, draw a new shape, like hand draw a new shape, and then export it or initialize it. So I would probably have like export select or add selection to list, and then it's going to pop up. So just like this one guy here, control set shape form, it would pop like a little dialog like this, and then we can add the name of the new shape. So say half circle. And the advantage then, one of the reasons why I was explaining how this works is because if we have a generic enough shape, say like a half circle or even a line, you can basically position or design the shape. So if you if you bring in a line with a bunch of vertex into a joint, then you can kind of stretch that lines and do whatever shape you want and save and export the modified shapes for on the rig, and then we can have like a very great flexibility in terms of types of shape that you can create on your rig, right? If you have a line, you can basically do anything. And yeah, so a half circle here, for example, I would like it would be initially a circle, but then I would drag it and just make it go on the closer to the jaw line here, for example. Right now it's an arrow. I don't know if I like it. So the next step after this then is to, right now the controls for the neck are just, the only way you can work with it is by dragging it around. So like this, it's not looking that bad. Let's see if we can check the deformation here. But this is not too bad, but also this is an initial bindings, and this will be better skin, but right now you have to hold each individual control to be able to work with it. So say if you grab the middle joint here, it's just grabbing one of the joints of the, in this case, the C3 joint of the neck. And what I want to do is have one single control here. Yeah, you know what? I want to do this, man. I would like to skip this step that I'm thinking right now with the curves. Mm. And add this module. So the module would then be a, let's draw a little bit more. So let me see if I can add a new, so where's the artboard tool? It's been so long I didn't use the, okay, never mind. Yeah, what I can do is just duplicate this guy here. So the neck here, so we have the neck with 1, 2, 3, 4, 5, 6, 7 joints, and then the head. Each one of them has their own control. Right? So the way we're gonna do this, is we're gonna have a ribbon or a geometry, doesn't matter. And then this ribbon will be binded into these joints. and then we're gonna have a control. What's going on here? So the control will be on a follicle. And look, what are you doing right now? Okay, so the control will be on a follicle here. The transform will be parented to this follicle, and then we're gonna have it like this. Stop it. Right? So then this control here will be controlling all of these guys here. So it will be driven by the movement of the joints, but it will be moving the joints as well. This might create some loops, some cycles. I don't know, but I've been there before. I think it works. Because it's just using the rotation, right? I don't remember if it has a cycle, but I do have the code already here. Okay. So we have the position data. Let me just give it a little description here. So to be gets our CV position data for each shaped node in the transform and returns a dictionary. And the data structure should be somewhere though. And this is the data structure. So I'm just going to paste it here as well. I'm just letting the script, or I'm just commenting on how the dictionary is being set up. This is the position data for one single transform, and we are storing multiple transforms into the into the JSON file, but this is just getting one single transform. Okay, so we have this. Now let's see what we need to do to get started. So let's create just a function here. Store should be something like store new shapeform. And I would require like the name, and I would start by the name. So it would be new form name, transform. Now, is that the best approach? I don't know. I'm just going to keep going. So the new shape name or the new form name is just the way the so say cube, half circle, whatever. This is the name of the preset. And the transform name is the one that's going to be containing that on the at the moment. So I would have to create a new object, and that's fine. I can then get data. So I think I'll do like self. God. So self. Let's try self dot transform equals to the new transform that we have in hand. So transform name, and then we would go and self dot. So basically, I'm changing the. It's no longer going to be the initial transform that the node creates, but then I'll have to delete it. Hold on. So first then mc dot delete self dot transform, and I will assign a new transform to it. Now get position data. Self dot control shapeless. So I believe that then yeah that would be actually okay. So the only flag is this, so I need to assign that to something. So it's position shape position dict goes to this, and then what I need is a way to assign that. Let's check the data structure again. Yeah, straightforward. Well, it is what we were expecting. Well, the function was right on top of it, but it's fine. All right, so we are then shape position dict is in hands already. So what else do we need? Okay, so we need the p. We need also the other information necessary to build the shape. So it's the knots, the d, and the per. So can we get the degree? We can get the degree? I know. So it's going to be my. I think it's just a simple query like. It's like my God, my computer is suffering right now. Come on, my curve get degree. I think it was like a curve query degree or something like that. I think it was pretty simple. Yeah, the degree of the new curve, but get degree. No, that's not what I want. Get attribute degree. Yeah, so that should be okay. So let's just test that just in case. So this one seems pretty round, therefore it must be a 3-degree curve. I'm just gonna check that CMDS dot get attribute, and it's going to be CMDS dot ls sl equals true, and then I want it's 0, and I'm just gonna do the worst thing possible here. Just do like plus dot degree. So just want to check how the information is going to come back to us. Yeah, and the result is 3. So that's exactly what we need. So we're going to do like curve degree. There's going to be cm or mc dot get attribute. Then it's going to be self dot transform, and then it's going to be dot degree and dot format, and that should be it. Now we have the degree. Now the knots. How can I query knots? Get knots. How do I find out knots value? Let's see if someone give us the answer for this. So if you this is the first 0. So thanks for the detailed reply. I'm struggling to understand the syntax. Would you mind explaining a bit? I really appreciate. What is actually going on when you this thread was just deleted or just didn't finish. So this guy's saying if you have a curve and you just want the knots see this page, you don't need to create the first and last knot as I do in the example here. It's done because every other NURBS package out there specifies knots fully. By design ignores the first and the last ones, but instead you can just get the results from the curve info node and pass straight back into the curve command. Let's check that. If you don't care about recreating the curve exactly for a cubic curve, for a cubic curve degree 3 order 4 that touches its endpoints. So this guy's actually was so the curve. So apparently on curve info node, do we have it? Huh. Okay, so I don't know that I care too much, but I would like to know the knots thing on the curve. It's always something that I think I should know. Yeah, insert knot. So I would assume that it's just what he said there. Like you can probably do it with, you can probably get away with just like zeros. If it's 6 knot, if it's 6 degrees, 2 CVs, 6 CVs would be then this. For a cubic curve, 3 degrees, order 4, that touches its endpoint. So 4, look at that. This is what I don't understand. 4 CVs, 5 CVs, 8 CVs. Ah, come on. Okay, we don't care about recreating the curve exactly. For a cubic curve, for that touches the endpoints, 0, 0, 0, 1, 1. I don't understand this pattern. 1, 2, 2, 2, 1, 2, 3, 3, 3. Yeah, it makes a little more sense, but still it doesn't make too much sense to me. If I want to give up this thing. Okay. Curve info node. So my curve info node knots. Can I query the knots attribute? Yeah, so this might be a good way to do it. Let's try that. So let's get the node editor here. And then it's going to be curve info, or before I even get started with that, let me add this curve here into the game. There's only one shape, great. So now I can add the curve info. Yeah, input curve. I would assume that the input curve has to be, doesn't matter then. Let's go with the world space here. Control points. And here we should have not information here. Why is then we have knots here? So this, let's just try to query this information here. So it's going to be also cmds dot get attribute, and then cmds dot, or pass in the actual name of the shape, curve info 1, and then I want to do, or actually it is just that, no knots. Okay, not too bad. Perfect, perfect. So it could be the local or the, but it doesn't matter. So what do I need? What I need here then? Wow, but then that actually, huh? Plant knots, weights. Wow, man, I've been slipping here, because if you get the curve points here, then control points. Control points. Don't I have though? Control points. Mixed type elements. Let's go with multi-index. It was like my Python get attribute. Just need to check what is the mi. equals true. Yeah, that's just giving us a bunch of stuff that I don't need. Hmm. Yeah, anyways, I don't need that right now. But to know that we can get the so we can get the degree, and then to get this knots information, we're gonna have to do a different thing. So to get the knots, then we're gonna have to create a curve info node. So it's going to be cmds dot create node. And then it's going to be a curve info. Just check if that's the case. But why is it complaining? Just do I need to have anything selected? What's the deal here? Show editor, whatever. So I don't know that it makes any difference. Oh, I see. So the difference between have like using the local or the world space is like how are you going to get this information here? So I believe that the local is going to give us one type of information, and the word space is going to give us a different. Doesn't seem to be the case though. So I'm just going to use the local here. Each shape is going to be a different thing. Okay. So then for shape and shape dict position. So I'm going to use the keys. We're going to do MC dot. So shape knots equals to MC dot, or first of all, is going to be create. So it's MC dot create node, and it's going to be a curve info, and then the name of this node is going to be temp curve info node. And this is a string, obviously. So it's the curve info node equals to this guy. And then I'm going to have to connect. So we're going to do cmrnc dot connect attribute. Then it's going to be the shape. It will be dot local. And then we're going to be adding a shape here. And that's going to be connected into our curve info node dot input curve dot format curve info node. Okay, so we have the connection done. The node was created. Then we're going to do get attribute. And then we're going to get the attribute that we need. So curve info node. Oh, there's going to be this guy dot knots dot format curve info node. So we have the knots data. So this data we will require. I don't think this is going to be too hard though. It's looking like we're going to get it. It's midnight already, so let me just get this going. So we got the knots data. It's fine. So we got the position, right? So what I need, this data structure is P and then the positions. So it's a completely different data structure. So let me actually do this then. So also I need to delete, after this is done, I need to delete the curve info node. Okay, so the data structure then must be different. New form data date has this sort of so the information that I need is the shape. So it's the shape name, which is the new form name. This is 100% going to be new form name and a new dictionary. So then now I have the shape, and that should be good enough for us to. So I would have to. Let me declare this before here. So now we get the shape, the vertex positions inside. So for the shapes, fine. Then I'm gonna have to reprocess this. So for shape in. Oh, actually, I'm already doing that, so I can. I believe I can then just use that same loop. But I didn't want to use the same loop though. Let's separate those loops. Let's see, I can separate it later. So let's start by transferring CV position data to new dictionary. Okay. So what I need then is, okay, so I have I'm inside the shape and I have the list for the shape. Cool. So the shape, okay, so then I need to get all of that's the position dict, shape P, and P is a list of lists. So we have P. So new form dot update or dot new shift, new form name dot update. That's going to be a dictionary. So then it's going to be the shape. Just trying to figure out the data structure here. The shape and a dictionary. Then, oh my God. So there might be a better way of doing it. And then I'm going to do shape dot shape equals dot update. That's going to be then finally P and a list. And this here could already then be our dictionary. Shapes position dict. And the shape. Shape position dict, yeah. Okay, I think that's it. P get knots and update to dictionary. So we should be able to then do like so here we're doing the same thing. So just like I think it's K. Cool. So K then. And it's just a list with a bunch of knots, I believe. Oh, I think it's a list inside of a list, so that should be an issue. So I'm actually going to then do like 0. Let's see if that's what we get. So that then should be inside of our dictionary. And the next and last thing is the degree, which we already have. So are we doing it, the degree? Let's see here. I just need to check if we are able to get the degree from the specific shape. So we can, and I would rather do that. I'm not sure if that's the case, that each shape is going to have a different degree. I don't remember ever seeing that, but it might be possible. It probably is possible. So get per shape per degree and assign the dictionary. And this is not going to be the transform, this is going to be the actual shape. And then we're going to be updating our dictionary once again. This time with D and curve degree. Boom. And then the last thing is per, which is, I don't know what's per. Seems like every one of them is false. Let's see if any of the shapes has a true per. But there might be, but let me check with on the curves. So my Python curve. Periodic. If on creates a curve, there's periodic. Default is off. What's a periodic curve? I forgot. My curve periodic. So the periodic curve can be periodic, closed, open, or an open form. So periodic, I believe it's a closed shape, right? Yeah. A periodic curve is also a loop with a sim. But it has two unseen spans at the end of the curve that overlap the first two spans. The unseen spans hold and help maintain continuity along the seam. For example, suppose you create a circle primitive with four spans section. A circle primitive is a periodic curve. If you display the circle added points, you see only four spans. There are actually six spans, but the last two overlap first two. Okay. So I'll go with period. I have to query the period if it's periodic, man. How do I get if the curve is periodic or not? For Christ's sake. So my Python get periodic. Good. So someone get attribute dot form. That's what it is. Great. I'm gonna be very happy. From zero. And what if it is an actual periodic curve? So poly or circle. Two. Hmm. So what? Get uh, either curve is periodic. So I'm just gonna go with like curve um, periodic. I don't know how to call this variable. And c dot get attribute, and if it's be shape dot form, format shape. Is that it? Yeah. So then if curve uh, curve periodic, I'm already going to do like a list comprehension here, or true or false if if zero equals zero, else true. I believe that should be good enough. So then it's funny that it's been stored with the lowercase true or false. But anyways, then let's just update this information. Per That should be it. So to get started with, what I'm going to do is just print this information. Let's see what it returns. So it's going to be new shape inform data dict. Cool. Fine. Store new control shape reset. So I'm just going to use the same thing here as I did before. So new control form reset name. Control preset name. Curve inst form. MC.lssl equals true. Cool. So we have both the new transform. So now I also need to create a new control. Okay. So I'm going to create a new object for this control. Let me see how I was doing it. So I'm just going to check where I'm adding the controls here. What's I think it's this one here. Just creating a new control. That's what we need. New preset control object. Temp control. Where? I don't know. Uh, and then I'm going to be calling this new preset object dot store new shape, new form name. It's going to be the control preset name that's being called there. And then the transform name is going to be the curve transform. And that should be it. I also need to register this. Self dot register build method, and it's going to be the store be control store new preset form. It's going to be in control tools and then self dot store new control preset. Great. See if it works. It is here. Great. So I should be able to curve tool. Something like this. It is in a transform, in the center of the world. New shape test. New test shape. And let's see. P with the position data of the with the position data of the CVs. Great, that's it. K with the knot, the exact knot. Amazing. Periodic freaking false. That's great. That's all that we need. So we are able to now store any type of preset. Great, man. It's bananas. I can't believe this is happening. Whew. Okay. Good progress. Good stuff. Okay, so now then what I need is to update the curve dict. Curve dict dot update. New shapeform dict. Let me check the data structure just to see if I'm not missing anything. No, that should be exactly what we need. And then I could also already call self.export curve to JSON. Easy. Dot export curve to JSON. This would be quite risky, but I could also just add this and it has to be here. Okay. Let's test that, right? Let's test that. Happy. So first of all, let me access this information here and save a backup because I feel like this could blow up in my face really hard. Okay, so I just then want to try the half circle thing. No, it's not what I want. So create, so I'm just trying to create like a half circle here. 5. Where's the front here? Okay. Ah, okay. Let's try again. This. Really helping me, right? Sections 8, circular, 1 linear. Huh. Got it. Oh, and also let me check the name. Is the get positions data is not going to get attribute multi indexes shapes. So it's going to be resetting the get position data. Let me see how am I storing here. So shape one, shape two. Okay, so I'm just gonna do it myself. I'm gonna restructure the data once again. Shape dot get position. It's fine. So here I'm going to add an index and enumerate this. New shape name. Shape rename equals shape underscore 0 to D. Format index. And then yeah, that's going to be a complicated change here. Shape rename. Shape rename. Rename. So the thing here is that we need to store in the same data structure as the current dictionary that we already have. This here's a half circle, pretty good. We should have like half. circle. That's it. Really? Okay. Let's see what changed and if we have the correct thing then. Half circles here. Awesome. Hmm. Perfect. Exactly what we needed. Except for one little thing here that I would like to be different. That is that it needs to start in one. With no big deal, I can literally just change it here for now. Let's rebuild this guy and let's see what we get. Okay, so there we have it. Oh, good, we're safe here. So let's test with this guy here. I want to go to the controls and then set shape form, and then it's going to be half circle. That should change us to a half circle. And there you go. Yes. Nice. That's it, guys. We got it. So let me just test the repositioning of this. So this is just what I was thinking of doing. I'm not sure if this is going to work. Like solid. It's actually on the jawline. So I believe that we can just add a little bit of a fall off here and just something like this. The color has been set properly. That's pretty interesting, actually. Hmm. Yeah, you know what? I'm gonna back up the last version and I'm just going to save this one, see if it works, and if it works, we're good to go. Time to go home. So I'm just gonna get the pro. Let's get to the project here. Data control shapes. I'm just gonna create like a backup folder here. I'm getting a little weirded out by this, the shape of this guy. So let me get it again. Just lightly. See now. Yeah, I think I feel a little better about it. I mean, maybe it's too far out, but it doesn't matter. It's just like a, it's just a test at this point. But the half circle, so you can see how flexible the half circle can be, right? And this could be done with any other shape. So let's export this now. And let's see if it rebuilds. Awesome. Awesome. Yes. It rebuilds. So as I always say, man, we gotta cheer for the small steps. And well, this took us actually another 2 hours to get going, which is a shame. But anyways, it's done, and we're not getting back from here. We're just moving forward. So yeah, happy about it. We have a new system to get these new shapes, whatever new shape I need to add into the control shape list. I can do it right now, so that's great. We can now we're free to, you know, use whatever form necessary now to create good looking controls or efficient controls. So just as a recap, so what happened today is we have the control system that is being parented to the joints, or the joints are being parented to the control system just like any other rig, and we need to store the positions of the shapes of these controls. And for that, we've been through an initial stage where we already have had some presets such as spheres, cubes, and so on and so forth, like just some basic shapes. And I still, aside from the presets that we had on the list, I didn't have a way to add more presets, and that's what we worked on today. So we can draw whatever it is on the scene and store this information on the preset JSON. Also, we got the mirror function to work. So with that, we're very solid on the control side. We might have to come back and make some modifications in the future, but we're certainly on a much better spot that will allow us to grow into whatever necessary into the next processes. So that's it for today. I am more than done. This is almost 1 o'clock in Vancouver, BC, and I am completely wasted. Gotta go. So happy though that this is working, and the next steps will be even happier. Now we can move into the system for the neck, and it will work like a charm. Or not. Probably not. All right. So you guys have a good night, and I hope you had a great weekend. Happy Monday. we're gonna make it. We're gonna make it. We're gonna make it in the professional, in the personal, and we're gonna be happy. I hope that for you. Cheers. Bye bye. Bye, Bob. Thank you so much.